Okay,
Uh,
so
sorry. I should I should join another device to hear you.
can you hear us now? Hello, can you hear us now? Hello?
I can hear you. I can hear you.
I think he got a
But
device
I think
problem.
he's remoted. He's remoted and cannot hear us, maybe.
Yeah.
Can you hear us?
Yes. Yes, I can hear you
Okay.
now.
Okay,
Thank
so we
you.
could start now. We have a mathematical introduction to Instanton.
Yes.
Okay.
So actually, I have changed the title from the Mina's paper of non-invariant to this because I have actually inspired from his paper that he has built a Dirac complex, and then uh, Mina says that the differential is generated by this instanton. So I want to get to know what is instanton. Then actually it is a physics term that appears in the non-perturbative aspect of quantum field theory. So, and it can be explained in the sense of differential manifold. So if we have a principal G bundle, and then we define a connection on the R4, and that so that I should make some presumption before this. So actually, in the investigation of Instanton, they are investigating on this R4. Then they look at a principal bundle, but they assume the group is actually a matrix group, and then also assume the Lie algebra of this G is also a matrix group. So under this assumption, the principal G bundle, they look at a connection on the bundle. Then a section is called a local gauge in the gauge theory, which is really they use to investigating instanton. And then the pullback of the section on the connection is the gauge potential. Then they somehow write the gauge potential is minus I times A. Then this A is actually the gauge field. And in their study, they actually say this A is also matrix. Everything is assumed as matrix. Then since we have connection, then we have a curvature coming from it, which we will define afterward also. So actually this curvature is, okay, I have a typo. This curvature is pullback of this curvature of the, I mean, the gauge field strength is the pullback of the curvature. Then we also write it as minus I times big F. Then this big F is satisfying this formula which comes from the definition of how we define a curvature on a connection. So moreover, this F is also a two form since omega is also a two form. So we will always get back the story backwards. So we from the end, then we go to the basic. Then actually instanton, we have a action, integral action on a curvature. And and then they divide by a constant to so that they can this by this S is actually always give you a integer. So this F dash star F, the star is actually the hot star operator. So it send any two form to the orthogonal two form and keeping the orientation. And instanton is what that minimize this integral so that by the calculus, then we know that it should be have the differentiation is 0, so that we get that this f is actually should satisfy f equals plus or minus star f. And then actually this f is equals to star f means it is self-dual on the hot star. Or if it has a minus sign, then we say it is anti-self-dual. Then we go back to differential manifold basics. So principal bundle is actually invariant under the right action on the group. And then if we, since the local trivialization is looking at the P inverse of a neighborhood and the neighborhood cross with the P, and then actually it has two and three. I have removed the word too much. Actually, this size is the second entry of the local trivialization, and it should satisfy this, that bringing out the right action to the multiplying the group element G. Then we come to the definition of the connections. Connection is actually just a one form that every right action pullbacks become a joint action of its inverse. And also it always send a vector field induced by this x to the x itself. I should mention actually all the one form is giving the value in the Lie algebra of G. So this is why we always looking at the Lie algebra. Then we have one important theorem in this project, that is, if we have a manifold and it has a matrix G, then there is a unique affine connection such that it is compatible with matrix and torsion free. This is important because the hot star actually is the definition is depending on the metric, because it is not only sending the like dx dy sending to dz dt. They actually have scaling by a metric constant, a constant that is depending on the matrix, I mean. So since the equation has the hot star, so actually if instanton we want is to starting from the hot star, then all the connection involved is actually this unique connection, then we call it as Levi-Civita connection. So we try to prove this uniqueness of the connection. Then we let the matrix to use the metric to calculate the covariant derivative of x on the y, and then with the z. Then we use the Cos-Su formula to get a relation between these x, y, z. Actually, since this right-hand side is constant and does not depend on the connection, then actually this implies the two connections should be the same because they are I come to have a jump that we look at a symmetric polynomial, then we can define a polynomial on curvature by putting all the entry as the curvature acting on two vector. So actually it need two k vector here for a polynomial of k argument. And then we need to symmetrize it and divide by 1 over 2k. We introduce that definition on the polynomial on curvature so that we can come to this theorem. That is, the polynomial on the curvature can always be a pullback of a unique closed 2k form. And then we say this closed 2k form is actually f bar omega. So you can see it can be determined by this polynomial we choose. So after the theorem, then actually it says that if you give me a symmetric polynomial, actually it should be we does not look at all the symmetric polynomial, but only look at the symmetric polynomial which is invariant under the conjugation. So actually polynomial on a matrix that is invariant under conjugation, we have no sum of them, like the determinant polynomial, and also the trace. Trace is also a polynomial. But then, since then we can actually define the f tilde can always get sent to a equivalence class of the Dirac cohomology. And then in our project, it also states that the choice of the curvature is actually independent to this map. And then in the Naber's book, it mentioned that in the left side, the group of the symmetric polynomial invariant under conjugation is actually and its multiplication is actually multiplication. And then under this map, it actually sends a multiplication in I into the wedge product. So it is actually a algebra homomorphism. Actually, to complete the proof that we have this map, we also need that this F tilde is closed. That is, its external derivative is 0. So since we have mentioned Dirac cohomology, then we come back one more step to introduce what is Dirac cohomology. Dirac cohomology is actually the chain complex, but all the chain complex is the closed K form. So we have the closed K form to close K minus 1 form until the close 1 form, and then close 0 form is actually the complex space. And then actually the Chen class is actually defined on this Dirac cohomology, and then the study of the Instanton is actually saying, actually claims that the integral action is equal to integrating a Chen class. This is why the Chen class come in. But before it, we have to consider the neighbor actually consider a determinant on lambda I plus I over 2 plus this A, where this A is actually coming from the Lie algebra of the G, which we assume E is a matrix. So E is a matrix, then we can have the determinant. And then this can be expressed as a polynomial on the matrix A times lambda n until it can be a polynomial of lambda, which is every coefficient is actually a symmetric polynomial of A and also invariant under the conjugation. So actually it claims that this Fk is in the I we introduced just now. And then by some induction, actually Fk is given by this I over 2 pi scaling by k exponential, and then we have a elementary symmetric polynomial. So like S1 is A1 and plus until AN, and then S2 is just A1, A2, A1, A3, all the two degree monomial sum up together, but they should not take the same. Then we say that this, our chain class is actually the image of this Fk under the homomorphism we introduced just now. And somehow they introduced the total chain class is C0 plus until Cn. Also, we have a important theorem here. That is, if we have two connections, and then the two curvature defined on these two connection, and we take a polynomial from the I, then the polynomial acting on these two curvature actually differ by just 2k minus 1 form. So what this means, this actually means that the two F omega is actually living on the same homology group in the, same equivalence class in the Dirac cohomology. So we try to prove this. So we define alpha is actually the omega 2 minus omega 1. Then we build a line between omega 1 and omega 2 by omega t is omega 1 plus alpha t. So actually omega 0, I should not let this t, but you can see if we take t equals to 0, then we get a starting point omega 1. And then we take t equals to 1, then we get the ending omega 2. Then actually how we define the curvature is, if you give me a curvature, then we say, if you give me a connection, then we say the curvature is d omega plus half the Lie bracket of omega and omega itself. Then actually using the same f we choose, then we define how we use the polynomial acting on k phi here. Here phi is actually the end form, but we does not require the end form to be fixed. So anyway, we just need this general definition of f taking many argument as some end form. Then we define this integral that we integrate the alpha big omega t and big omega t. Here actually there are k copy of the omega t, which is the curvature on the omega we defined just now. Then we consider this, then actually the integration will simplify to is just the f bar omega 2 minus f bar omega 1 integration. So how this is achieved? So we consider the Lie bracket of omega t, then we expand by its definition, and then we differentiate, and then we can see it is just double the Lie bracket of alpha and omega t. Since this alpha is constant to t, so if we differentiate to t, it does not change. Then we have the curvature. Then we look at the differentiation of the curvature. So this differentiation on the omega t is actually giving the alpha. So differentiation on its exterior derivative also give us just d alpha. And then differentiation on the half Lie bracket of omega t give us the alpha with the omega t doing Lie bracket. Then we look at k times the exterior derivative of the f. Then actually we can, by the theorem of external derivative, we can put it inside the polynomial, since this is just symmetric polynomial. Then we have k copy of the symmetric polynomial, which one of its entry actually we can see is just the differentiation of omega t. Then actually it is just the differentiation of the whole polynomial of the omega t, since it is just by the chain rule. So finally, we can see the external derivative of the construction of the phi actually give us the f bar omega minus f bar omega to 1. And this phi we define is actually the 2k minus 1 form we want here. So as a remark, actually in the Instanton, there can be some special example. One of the example is maybe we take the group to be the special matrix group and unitary. Then actually the total space of the G bundle we just take as S4. So anyway, this Instanton, actually the integral action will give us a integer, then we call it Instanton number, and it is topological invariant. What does it mean? So it means that if we change the total space to some other topology, to some other manifold, it actually does not change much. So we can just say that is integrating this f dash f, taking the trace, and then divide by minus 8 pi squared. So I think my presentation ends here. Thank you.
Okay, we have 2 more minutes. So Arash, do you have any question?
Why connection exists?
What?
Why connection exists on a principal bundle?
The connection exists.
Yes.
Mm,
He said that if omega satisfies some property, we call it a connection. Why a connection exists?
mm.
Maybe it's empty. How we are sure that such omega exists?
I mean, we can always find a omega because
If we have a
know.
trivial
Sorry.
bundle, what is the connection on a trivial bundle? Do you know?
I
On a
know
trivial bundle, how it is
it's
defined?
for trivial connection, but sorry, I cannot give how we define a connection. Sorry.
Okay, no problem.
Actually, I am
but
sure Naber's textbook have give the how the connection always exists on a given bundle, so
yeah,
we don't have to
the idea
worry.
is to prove that the connection exists on trivial bundle and every principal bundle is locally trivial. Then you use a partition of unity to show that the connection exists. Okay. So another question, why you prove that Levi-Civita connection exists? Where you used it? Why you need that?
So I mean that because the Hochschild actually depend on the metric. So actually, if we are investigating Instanton, the connection involved here is actually the Levi-Civita connection. It is not the trivial one. I mean,
This I don't understand. This omega is for Levi-Civita connection?
Yes, it should, because this omega here, it gives the f, it gives the
No, I'm
curvature on
talking
the
about Levi-Civita connection. Why you need it? You proved the existence of Levi-Civita connection. I want to know how this is related to the rest of the thesis.
Just,
It's
that
something
is,
separate you prove, or it is related? You
this
need
f,
you need
yes, this
where?
f should be actually a curvature on the Levi-Civita connection. But since this f somehow is a
But I
pullback of
don't think
the,
I don't think that's it, because you fix a connection on some bundle. Okay, anyway. Okay, thank you.
yes, okay,
So your F is just on R4, is it?
F is
yes,
curvature of connection that
it,
you fix, the local field that you
He claimed
consider.
that the connection is just Levi-Civita, and then he looked at the curvature of the connection. Is that right?
yes, I can read.
It's not correct.
Why is it not correct? Can you tell us more?
Sorry.
It's not correct because this is not how you define this. What you have here is chain wheel theory, right? What you proved, you explain is chain wheel theory.
Yes,
And for chain wheel theory,
it's a
you
real
can
theory.
fix any kind of connection. It doesn't matter which kind of connection you choose. Then what you obtain is some kind of characteristic class. Okay, it can be chain class. It depends what polynomial you consider. And then you will get some topological invariant. You don't need Levi-Civita. I don't understand why you need Levi-Civita.
So is there a reason you want to fix your connection or not, Ziqian?
No, sorry.
So you
Because
just
we said
Just
this,
because
you
here is
said that instantons are the stationary port of the Yang-Mills action. Okay, this is what we have here. Action functional. This is Yang-Mills functional, right? Yang-Mills action. So if you consider a variation here, the stationary point will be the instantons here, right? So it will be
yes,
for any connection that you fix
yes,
on your bundle, not for Levi-Civita. Because if you take Levi-Civita, then the curvature will be Riemannian curvature. You want to find the connection
okay,
here. Actually, you want to find the connection such that its curvature is a stationary point for a stationary point of this functional. So if you fix Levi-Civita, then it doesn't make sense at all,
okay.
I think.
Do you understand or not, Ziqian?
I, I I understand.
I know
Maybe
that
I
the
will
subject is
take a
difficult.
look later.
You did a
No,
good job.
it's okay
Don't
about
feel
difficult.
bad.
I want him to like figure out what's wrong with him because he cannot figure out sometimes what's wrong with him. So he should learn how to listen to people's opinion.
Can
You
you
understand what
say it
RS?
again, sir?
So RS
Yes.
is saying that if you just fix connection, then either this answer will work or either don't work, but there's just only a particular solution. Maybe you could find other connection for this anti-self dual to hold. Is that right?
Okay.
Yeah. So if you just fix connection, then it's not very interesting in Arash opinion, right? The point here is to find a curvature or connection to work such that you have this self-dual answer here.
Okay.
Yeah.
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 What is this G squared here? Okay,
Here,
maybe we have to finish, but can you explain just what is this G squared here?
G square. So like if we choose the Qian class, so this G square actually is just the 4 pi square. So actually the 2G square here is just to make this integral become an integer. It's just scaling.
Okay. Nothing to do with the metric that you have. You have a metric on R4, right?
Yes.
What's the definition of G?
What is the? No, until what I learn now, I don't know.
I mean, like, you should. There's a lot of like missing thing inside all your definition slide, right? Actually, and then you mentioned a lot of things. Are you writing them into your thesis or not?
I think you should. You should have maybe some 3 parts, something like 3 parts in your thesis. Okay. So one part you talk about chain well theory. What you proved, it was chain well theory that you have some characteristic class, etc. Okay, you start with some connection on a principal bundle, any principal bundle, and then you continue. You find some topological invariant, right?
Okay.
That is one chapter. Can be one chapter separate. Okay, it's something totally general, nothing related to instantons, right? For instantons, you don't have that much because it's a difficult subject. I understand. You only have the definition, almost something like just the definition. That's what you can do. Then it becomes very fast difficult, and it's not your fault that it's difficult. Okay, so you did a good job to choose some subject as difficult as it is. And the Levi-Civita connection, I don't know how it can be another chapter. I don't know how you can include it.
Can you say again the second part?
What you asked?
Sorry, sir. Just now the Teams light already. So can you repeat the second part?
Maybe Qian can help you better, huh?
So
how to rewrite this, how to organize this. Maybe you have to change also the title. It's just my suggestion, okay? What I have seen here is more the proof of Chern-Weil theorem. So it can be, for example, introduction to Chern-Weil theory, something like this.
Okay.
Because you don't have that much from the instanton, so the title is not very relevant to me. You can think about it. Okay? You can think about it. Because you only can say what is the definition, right? You cannot say more than that. Yeah, but at least for chain-well theory, you can say what is a principal bundle, what is connection, then proof of it, etc.
Yes.
Okay. Yeah.
Thank you.
No problem. I had this as a project, so that's I know it. I know it very well. So everything is familiar to me. That's why I'm talking too much. Okay. Don't worry.
Arash, can you include your comment into his thesis so that he can improve? Yeah.
I try.
Because the point I want to have this thesis, actually, I also start from scratch. I want to learn about this topic here. So I asked him to figure out what I need to learn somehow. So he have to like bring out all the background. Yeah. So yeah.
Sure.
Yes. Okay, in that case, thank you very much. Thank you, Arash.
Thank you, everyone.
Thank you very much.
Okay, happy weekend.
Bye-bye.
Bye-bye.